All right, guys, welcome back to another fun-filled day of SAT prep. It's good to see you guys again. Once again, my name is Mr. Anthony Wyckoff. I'm one of the directors and owners of Embrace. We are going to be working through the dividing polynomials as well as an equation of a circle. I believe some of you reached out and asked to do one of the advanced triangle problems as well as kind of some of the perimeter, square, circle, etc. So we're going to be revisiting a few topics for today for problems that you guys have asked for. But I do want to always encourage you to utilize the chat feature inside of the kind of the little toolbox to make sure that you guys are in a good spot. Okay. We're getting started on page 72 of the 189 page PDF for dividing polynomials. I'm going to show you guys a few quick kind of hacks. As always, this information will be provided to you online through various recordings. Okay, so here we have, and let me kind of minimize this. Here we have, it says which of the following is equivalent to x squared minus 2x minus 5 over x minus 3. Now, to be fair, a lot of times when you see this type of problem, and because of the verbiage here where it says which of the following is equivalent, one of the things you can primarily do, and something I hope that you notice, is that this classically is what your teachers a lot of times will refer to as like synthetic division. But what you can do, kind of a quick SAT hack, if you will, is that whenever you see this phrasing here, you actually can choose a number, and you can choose a number to plug in. So I'm going to solve it both ways, so that way you kind of get a general idea of what I'm doing. But you can choose a number to plug in. And when you plug in a number, because I see this verbiage here, I see variables here inside of my expression, and then all of my answer choices also have variables. So I can essentially kind of simplify by choosing this number and then plug in. The number I choose most often is usually actually not zero. That's the thing that most students choose. I'm actually going to choose 1 because 1 will meet almost all of the conditions more often than not. And if you need to choose another number, then usually you might want to choose something like x equals 2. And sometimes you'll notice, and as we do other questions, you might see questions where they will give you inequality, where it'll be like x's has to be greater than 3. And then if that case, right, then you want to choose x equals 4, right? You want to choose the next number in the sequence to make it easier on yourself. So here's what I mean, is that if I'm choosing a number here, I'm going to take this and I'm going to take, hey, I don't see any of the, hold on one second. I see a couple questions, and I'm just going to kind of make sure that you guys are good to go. And Brielle's asking, hey, I don't see any of the writing on my screen. It could just be for me though. Interesting. Okay, hold on one second. Let me see if I can. Okay, I think you should be able to see it now. So okay, okay, great. All right, awesome. Thank you for stopping me. So before I got like 5 problems in, I would have felt bad. Okay, so here we go. Right. So choosing numbers in general is, when you're doing this strategy, is I'm attempting to choose a number where I can plug it into the top expression. I simplify and solve. I then would plug it into my answer choices, and whichever of those match, that is going to be your answer choice, because therefore they are going to be equivalent, right, across the board. That's the idea, right? They're then going to be equivalent. So I'm gonna plug it into the top expression here, where I get 1 squared minus 2 times 1 and then minus 5. And then this is going to be over 1 minus 3, okay? 1 squared is 1, minus 2 times 1, right? Order of operations here, just general order of operations, is going to be 2. And then so I have 1 minus 2 minus 5. And this is going to be, so 1 minus 2 is negative 1, minus 5 is going to be negative 6, okay? And then 1 minus 3 is going to be negative 2. When I do negative 3 over negative 2, my answer choice should be 3. If I theoretically plug in a 1, my answer choice basically I should end up getting 3. Now, if I look at my answer choices, here's where I'm going to do a little bit of arithmetic. Okay, if I look at my answer choices, I have x minus 5 and x minus 5. If I plug in a 1 here and a 1 here, I'm getting much further away from 3. So I'm actually probably going to start with C and D first, because if I plug in a 1 here and if I plug in a 1 here, I then get 2, right? So I get 2 and then 2, right, as I plug this in. So I'm going to try C first, where I get 1 plus 1 equals 2 minus 8, and then I'm going to get 1 minus 3. So here I end up getting, when I simplify, I get 2 minus, and then this is 8 over my negative 2. 2 minus 8 over negative 2, the 8 over negative 2 becomes a negative 4. So I end up then getting 2 minus, and this would become -4. So remember, a negative becomes a positive. So 2 plus 4 equals 6. So this won't work, right? C shouldn't work. It's probably going to end up being D in this case, because I can already see it's 2, and it's going to be 1 minus 3 is going to be -2. So if I erase this, okay, and as always, I encourage you to take screenshots along the way, whatever is going to be easiest for you, and feel free to utilize the chat, okay? So here I have 1 plus 1 minus 2 over 1 minus 3. Now, 1 plus 1 is 2, minus 2 over -2. This 2 over -2 will simplify, and it will become 1 minus -1. 2 minus -1 will become, right, negative and negative is positive, so this does become 3. So D will be my answer choice when I plug in x equals 1. And I guarantee you, so when I plug in x equals 1 here, I end up getting 3 for my answer. And if I plug in x equals 1 here, I end up getting D for my answer. And that is what it means for the expressions to be equivalent. So that's a quick hack whenever you get stuck, right, on the SAT in general. It's something you can always do for any type of problem. And I've seen a number of my students utilize the strategy if they get stuck. Because one thing you'll notice is that the SAT will change the type of math concept that they might have you do, even depending on, you know, these what we refer to as which of the following is equivalent problems. Now let's pretend classic math, right, to make your math teachers happy. Classic math looks like this. So this is x squared minus 2x minus 5, and then let's do some just general division. Here I have x minus 3. Classic math for synthetic division is I have to figure out how many times does this x go into this x squared. It goes into it x number of times. The -3 does not go into the x. X times x gives me x squared, right? X times -3 gives me -3x. But I need to remove this, so I need to subtract these out. So I'm going to change the sign. So this becomes like a negative, and this would also become a negative, which therefore I'm going to make this a positive, okay? So now I no longer have x squared, part of my remainder. I now have -2x plus 3x, right? Because it would have been -2x minus 3x, so it becomes -2x plus 3x, which this is what gives me an x. Now, and I'm going to bring my -5 down. So now I'm doing how many times does x minus 3 go into x minus 5? And when I do this, I have x, right, goes into x one time, right, +1. That's right, that's what we're matching up previously for our other answer choice. And notice what I should end up getting is D, right? If I do this the right way, I should get D. But I was just showing you the other way, like the hack. That way it makes it easier regardless of whatever type of dividing polynomial question that you get. So 1 times x gives me x. The -3, right, won't go in. So I do 1 times -3, which will give me -3. Now I have to subtract these again. So I'm going to do the -x and the +3. This will end up giving me a -2, right? So these x's will cancel, right? These x squareds cancel. And now look what I'm in. -2 is my remainder. That's how I would label this. Because of the fact that x does not go into -2, right? That's why I label this to be a remainder. I can no longer do these. And what you want to do is you want to take your remainder and you want to put it over your original, what you were dividing by, right? That's your original kind of what it is that you were setting this up and as you were dividing by. So here, right, I should have -2 over x minus 3, which is exactly what you see here. So my overall answer will be written as x plus 1, and then -2, right, over x minus 3, which is D. So those are two different ways to do that problem. One is classic math, right? And the other one is kind of the SAT way of doing it to make it a little bit more efficient, depending on the type of problem that you have. Okay, let's take a look at one more. And I can come back to this one as well for number 8. It's kind of a combination of things, but this is kind of a little bit more classically of what I'm referring to. And let me check the chat real fast just to see if you guys have any questions. Could you also use the FOIL method? And this is from Caitlin. So you could technically, I believe, use the FOIL method. I don't really know if that's the most efficient way to do it, given what they're providing you. It's a really good question. I would tend to, and this is, to be fair, this is actually just because of like my experience with the SAT. when you're doing which of the following is equivalent problems, like referring to 13, you could FOIL this out. And I think actually, if you FOIL this out, it's actually better geared for the, let me see here. There are questions where you can use the FOIL method. I don't really know if that one would be the best, only because of the fact that you see the remainder under here, right? So technically you could use the FOIL method, but it might take a little bit longer. So this part here, I guess to make it easier for you guys, this part here is a huge idea that this is synthetic division, right? Because I have this is over the original, so that's probably where the idea of using synthetic division is basically coming from. Because of the CI, I see the verbiage, which of the following expressions is equivalent. I immediately know if I get stuck, I can plug in a number, right? Or if I immediately know that if, hey, I don't recall how to solve this classically, or I forget the factors if I'm doing FOILing, right? Generally speaking, I tend to just plug in numbers because I will do majority of it as much as possible in my head to kind of simplify it. Okay, I hope that helps to kind of clarify things. But the most important thing is there's always more than one way to kind of solve the problems. Okay, all right, let's do this problem, right? So that way you can kind of see what it is I'm referring to. So once again, I'll do it both ways. There are instances where one way is usually faster than the other, but I generally just tend to, which following is equivalent, boom, choose a number. I can choose 0 in this case, but I'm probably going to choose x equals 1. Be prepared that you might have to do, because of the fact that you have a square root here, you might have to plug in another number like s equals 2. I'm going to plug this in here. I get 3 times 1 squared plus 5 times 1, and then over, and then I get 3 times 1 plus 2. So the bottom here, right, 3 times 1 is 3 plus 2. This will give me 5. 1 squared, remember order of operations is 1. 1 times 3 is 3. 5 times 1 is 5. So here I get 3 plus 5, and this should give me 8. So I should be getting 8 over 5 when I plug these answer choices in. I'm now going to take my 1 like as such, and I'm going to plug them in. I can immediately tell it's not this, right? Because this is not 8 over 5. I can immediately tell it's not 4, right? So I'm immediately A and B are gone, right? Here, this would give me 0 and then minus this, right? 8 over 5. So I doubt it's going to be this. So once again, I'm going to plug into D, right? And just using some logic to kind of break these down for what I can solve for rather quickly. So then I get 1 plus 1 minus, and then 2 over, and then 3, once again, 3 times 1, and then plus 2. What you will notice, and to kind of help you guys out, is that once you solve for the actual denominator, don't overthink that. They're going to keep using the same ones. So I already solved for this, right? This is 5. So I already solved for, this is 1 plus 1, right, minus 2 over 5, right? I already solved for this part here. So don't think that you have to keep solving for it, I guess is basically what I'm saying. So here's 5, right? Here's 5. So you can just cross them out and then use them to your advantage. So now here I have 2 minus 2 over 5, and you can already tell that now that I'm dealing in fractions, I have to find my common denominator. So this becomes 2, and I want this to be, apologies, moving a little bit too fast. I want this to be over 5, and I want this to be over 5, so I can subtract. Well, how does the 2 over 1 become something over 5? I have to multiply both of these by 5, so 1 times 5 is 5, therefore 2 times 5 is 10, and what would you know? I end up getting 8 over 5. So D, once again, will be our answer choice for this. And I could do the synthetic division again, so you can see it, but instead what I'm going to do is move on to another type of problem, so that way you guys can see that one as well, okay? I'll do one that actually requires a little bit of factoring, okay? And I'll show you both ways, right? So that way you can have a better understanding. So I will do the factor method, and then I will do the which of the following is equivalent method, right? Where if I plug in. And matter of fact, what I'll do first, because there's strategies to both, just to help you, is I will do the plug-in method. So I'm going to do over here, I have, this is which of the following expressions is equivalent to f of x over g of x for x is greater than 3. Remember, don't don't be a hero, right? Don't choose a number that's like so crazy that it doesn't make a lot of sense, because a lot of these questions do come in the non-calc section, so you need to be prepared to do the math rather quickly. Most of the time, as hard as it gets, honestly, is just subtracting or adding fractions together when you simplify this. So here, if I'm going to do this, I'm going to choose x equals 4. If I choose x equals 4, then I'm going to plug it into both of these expressions. I get 4 to the third minus 9 times 4. And then this is 4 squared minus 2 times 4 minus 3. Now, 4 to the third is going to be 4 times 4 is 16, and then times 4 is going to be 64, right? So I'll just put this in a different color where you guys can see it. So this is 64, and then this 9 times 4 is going to be 36. So if I do 64 minus 36, and let's pretend this is in the calculator just to save some time, this would be 28. Okay, if you needed to plug that in. So here I have 4 squared is going to be 16. Then minus 2 times 4 is going to be 8. And then minus 3. So here I have, this is minus 11. 16 minus 11 is going to be 5. So my answer choice when I plug this in, and I hope this is helping you guys like just see the problems in different ways regardless, because that's one of the advantages I feel like of working with this, is that we don't teach it just in terms of like classic math. Yes, we want you to be able to understand mathematics, but certainly we want you guys to be able to visualize the problems in terms of like problem solving more than anything else. So now when I plug in x equals 4, I should get 28 over 5. Well, we can do this rather quickly, right? Once again, this is, if I plug in 4 here, this is 5, okay? My denominator is 5. Well, my denominator here is 5. Well, my denominator here is 5. Well, my denominator here is 5. You see what I'm doing, right? This is not 28 over 5. This is 1 over 5. So that's gone. This also is going to be 7 over 5, right? Not 8 over 5. So this is going to be gone. Well, that one's not going to work. This one here might be close, but it's going to be, let's see here, 4, and then 4 minus 3. So then this is going to be a 1. 4 times 1 is going to be 4. So this would be 4 over 5. Also not going to work. And right, the right, the trifecta, the answer is probably going to be a D again. And it is, because here I have 4, and then 4 plus 3 is 7. So 4 times 7 is 28. 28 is my answer, or what I'm expecting when I plug in, right? So these two things match, so I'm happy, right? So D will be my answer. Now, let's do the factor way, just to kind of make sure that we're all essentially up to speed and in terms of what you guys need, okay? And let me go back. I'm just checking the chat periodically, make sure that you guys are getting the most out of it, but feel free to just drop anything inside of the question box as well, okay? Now I'm gonna delete this just to make some room. Okay, we already understand that D is going to be the answer choice, but let me kind of walk you through the other way to do this. As we are, let's pretend you prefer to factor, because it's actually by far more important on the SAT than just doing other things. So here's what I would do if I'm going to do my factor method. So let's kind of quickly repeat the problem. Always, you want to identify what is given inside of the problem, and that does include the answer choices. And you want to figure out what is kind of I would say the concept of whatever it is they're asking, like kind of triaging the problem. And then you want to use your answer choices as a guide as you're attempting to solve through. So here I have x to the third minus 9x over x squared minus 2x minus 3. One thing I notice is that all of my answer choices have an x plus 1 in my denominator, which tells me that this x squared minus 2x has been simplified, right? And the simplification is what you refer to as factoring. Yay, right? So I'm gonna factor this x squared minus 2x minus 3. And I should have, like theoretically, I'm using this as a guide, my x plus 1 needs to be a part of my answer choices. So this x plus 1 should be a part of this, and it is, right? If you factor this appropriately, what you're going to notice is which two values multiplied together will give you a minus 3, but when added together will give you a negative 2. That is an x plus 1 and an x minus 3. I encourage you, if you need help with factoring, to really explore and kind of go grassroots, go talk to your teacher because in general, and what I've noticed is that math really compounds, right? From algebra 1, geometry, algebra 2, pre-calc, etc. And factoring is kind of one of those skills that regardless of the level, they will expect you to be able to do this and do this well. So if you get stuck on actually how to factor things or kind of quick tips, then excuse me, I definitely explore you to kind of investigate a little bit further, because it's a skill that you need regardless of the level of mathematics. All right, so here we have x to the third minus 9x. Here's one quick tip I will give you. Now that I have x minus 3 in my denominator, I'm thinking to myself, okay, well, I have to have that somewhere, right? Because technically these should have crossed off. So if I factor this, let's see what I have here. I can take an x out, right? That's my common between these two things. So I'm going to take an x out, and then I get x squared minus 9, right? And then most students would think to themselves, okay, well, what do I do now? I will tell you a huge hint on the SAT is always notice if you have something which is referred to as like a difference of squares. And the difference of squares is essentially like if you have like x squared minus 1, x squared minus 4, right, x squared minus 9, right, x squared minus 16. What you're going to notice is that these here are all perfect squares. So if I have like an x squared minus 1, this is really like an x plus 1, right, x minus 1. They love to do this too, right? They'll do this as well with like x squared or a squared minus b squared. They'll do something like this all the time. So whenever you have two perfect squares and a minus sign in front, it's a huge red flag that you're probably going to have some sort of difference of squares. Now, it is the case in this instance. And if you don't notice that at first, what you want to pay attention to is what you want to think about. And why is there no x minus 3 in my answer choices? The reason is because this has been solved further. And this becomes x times x minus 3 times x plus 3 like this. And then I divide, of course, by x minus 3 over x plus 3, or I'm sorry, x plus 1. Now notice what happens. My x minus 3 is in the numerator. My x minus 3 is in the denominator. Well, boom, I'm done, right? So I can't simplify this any further. And when I set this kind of when I simplify it to its best form, I get x times x plus 3 over x plus 1. And what would you know? We still end up with d as our answer. So that's what I'm trying to kind of illustrate to you, is that there's multiple ways to do a lot of these problems. If you seriously get stuck, you can choose the kind of the plugging in method for what is stated. But at the same time, there are certain skills that the SAT really takes for granted. And one of those skills primarily definitely is being able to factor and being able to really interpret what the question is giving you. So if you do get stuck, a huge tip that I will give you is use the answer choices as a guide to help you kind of work through. I knew that x minus 3 needed to be in my numerator in some capacity because of the fact that it's not in my answer choices, right? So use the answer choices as a guide if you seriously get stuck. I really hope that helps you guys. All right, let me check the chat one more time, so that way we can address anything, questions. It's all good, Heather. I hope your cat is getting the most out of SAT prep. So, all right, here we let's see here. Let's go down to some of the, I don't believe you guys have had a chance to kind of quickly review the equation of a circle. So I want to go to page 142. Let me do this here. So we're here up top where it says page 87. I'm going to slide down. I'm going to go to page 142. Okay. And we might even start, to be fair, with one of the later problems, just because I think that would help you guys better. Yeah, matter of fact, let's start with this one, right? This is a good warm up for equation of a circle, okay? Now, for equation of a circle, let me just position myself here. First of all, this is probably the most popular equation that is on the SAT that they do not give you, okay? So one major master tip I will give you is when you get your test booklet on the day of the test, because, and I'll show you in a moment. Let me see. Let me go here. Here's the March 20. Okay, so one of the reasons I'm showing you this is that when you actually get your test booklet, on the day of the test, you're going to be given a reference section for the mathematics. And that reference section is going to contain really valuable equations. Probably the most popular equation, though, that I've noticed that they do not give to students that generally often appears on the SAT is equation of the circle. So you'll notice here, right, they don't give this to you. They'll give you volume of a pyramid, right? They'll give you Pythagorean theorem, area of a triangle, right, area of a rectangle, even area of a circle. They'll give you all these things, including some special right triangles. But one thing they generally do not give you is special right triangle. So here's a quick suggestion that I will make to you. On test day, you want to be prepared to write this equation down right when you get the test. And here's the reason why. You most likely will get this in section 4, okay? And if you're doing the math thus far, you will have already taken almost 2.5 to 3 hours of this test before you get to section 4. That can be a little overwhelming, right? So what you don't want to do is, like suddenly forget everything. And it just helps you to just, when you get your equation of a circle, kind of like or when you get your test booklet, you just simply write this down and you say, okay, this is what my equation of a circle is going to be. And I'm going to kind of break it down for you for what these things stand for. All right. First of all, equation of a circle a lot of times is usually related to, they'll do parabolas and they will do circles and they will do vertex form. Okay, those are things like that all kind of go together. And that's simply because, like, look here, if I drew like a quick schematic, here's my half a circle, right? But also notice what I drew. I drew a parabola, right? So this is my vertex. If I drew the other half, now I have a circle. So that's why these things all essentially come together mathematically, all right? Now, the question is, what are the H and what are the K? And I hope you somewhat recall that you've seen these before in other types of equations, like the vertex equation, but my H and my K here are both going to represent my center of the circle. Okay, this is my center point of the circle. The R is representing your radius of the circle. Now, do notice that it's just R and not necessarily R squared. And do notice the H and the K here are without the negatives in front. So the negative H and the negative K are how the equation of the circle is written. However, the actual center of the circle, what we're going to identify, you kind of have to flip them. Basically, you have to flip them through what it is. All right, so let's break down this question, and we'll do harder problems, right? We'll kind of elevate up. So here we have circle in the equation has a center of 5, 7, and a radius of 2. And so here's my center. And it says, which of the following is an equation of the circle? Well, in this instance, they're giving me everything I need. I simply want to plug in. So here I have x minus, this is my x or my h coordinate, which is my 5. I notice it's a positive 5, so I just plug it in as such. And then I notice here's my positive sign, which stays the same. And then here's my y, and then minus, and then here's my k, right, which is going to be 7. Also, this appears as minus 7 because it is a positive 7 for my circle. And then here we are. X minus 5 squared plus y minus 7 squared equals, and then this is going to be r squared. And so this is going to be 2 squared, right? So 2 squared, you might already be paying attention to, is going to be 4. And when I simplify this, the answer choice is probably going to appear as a 4, which it does. And notice here, this is the x minus 5, x minus 7, 4, done. So A will be my answer choice for this problem, okay? The H and the K both represent the x and the y coordinates of the circle. The R represents the radius of the circle. And quick recap, the R, or the radius of a circle, is just the center to an outside endpoint. That is what the R represents, right? If you go all the way across, then that is what you refer to as the diameter of the circle, which cuts it exactly in half, okay? All right, let me pause real fast, and let me check any questions you guys might have. And okay, we're good. And let me just make sure also at the same time that we are, yep, okay, we're good to go. Remember, the video as always is going to be posted for you guys, so that way you guys can have it, okay? But to get the most out of this, feel free to obviously comment and participate in the chat, so that way it makes it easier. right, so here we have, so another kind of warm-up question, making it a little bit easier. It says a particular circle in the standard xy plane coordinate has an equation of x minus 5 squared plus y squared equals 38. Well, if I have x minus 5, okay, squared, and this is plus y squared equals 38, then now let's label these things. Where did they come from? All right, so remember, this minus 5 here was coming from the h. Okay, so this is the h, and we don't see it here, but the k should have been written. Okay, the k, because of the fact that this is a y squared, is going to be 0, right? This would have been y minus 0 squared like this, and this is 38. And then here, notice because this is a minus 5, right? If I wrote that as such, that means that my let's say minus 5 here is going to be equivalent to, because this should have been written as minus h, right? Remember, this is a x minus h squared plus, and this would have been y minus k squared equals 38. And let me break this down. There we go. So my negative 5 here, my minus h, this means that h will equal 5. The way that I generally do it, because I've become accustomed to kind of just doing these rather quickly, is you take whatever is inside of here, and you very well remember that it's a minus h and a minus k, so you just flip the signs, right? So if they have, basically, if this is like a minus 7 inside of this, right, inside of this here, then it's almost like solving for a root. You basically flip the side of it, or flip the sign of it, so that way it becomes x equals positive 7, right? So in this instance, that's how you figure out. So my center here is going to be 5, okay, and my k from my y value is going to be 0. So there's my center. So my center is going to be positive. So I'm going to get rid of these, okay, j and k. And then what I notice here for my 38, well, remember, this is r squared. So 38 equals r squared. So I have to simplify this to solve for r. So I'm going to do the radical on both sides. I'm then going to remove my exponent here, and then I get radical 38 equals r. Let me see if they simplify this anymore, which I believe they don't. And here we are. F is our answer. All right, so radical 38 will equal r, whereas r squared will equal 38. But they're just asking to solve for r, right? That's the idea. They're just asking to solve for r of the circle, not r squared. So you want to pay attention to that. So thus far, we've done one where we give you the coordinates and you fill in the line, and then we've done another one where we give you the line and we fill in the coordinates. Okay, let's do one that's a little bit harder, so we can see. Now for this problem here, okay, the slight issue in what you want to pay attention to, and I mentioned before that the word vertex is related to the equation of a circle, and the reason being is that equation of a circle is because vertex is, the equation of a circle is in vertex form, and that's what these are referring to. So my x minus h squared plus my y minus k squared equals r squared. That's what you want to pay attention to. So because of the fact that these are in vertex form, basically what I'm saying is that these are kind of like a perfect square in itself, right? It's something times itself, which is why it is getting to be an exponent of 2 on the outside. Because of the fact that you need to do that, what you're going to need to do whenever you have something in kind of what is like a common form, or sometimes like a standard form, that's what you see here, where you have x squared plus 20x and then plus y squared plus 16y, right? In this case equals negative 20. What you want to do in order for you to convert this form here into this form, okay, there's a method by which we refer to as called completing the square, which I hope some of you like recall of what that is, right? But what you're to notice is there's kind of a system of how you complete the square. All right, so let me erase this real fast, and I'm just gonna kind of rewrite it to make it a little bit neater, because here's what you want to do. I have my x squared plus my 20x. I'm purposely going to leave a space here, knowing very well that I have to go from this to my x minus h squared plus my y minus k squared equals r squared. Okay, I'm trying to purposely take this to a vertex form. So I'm purposely leaving a space. And here's why you're going to see. Also notice I'm purposely leaving the x's near each other, and I'm going to do the same for the y's. So if they are not near each other, that's what you'll have to do first. You have to bring them together. And I'm going to leave a space here, and this is going to give me negative 20. Okay, so I'm purposely going to leave the x's near each other, and now I'm going to leave the y's near each other. Well, when you do complete the square, what you do is you take your middle value, okay, and then you divide your middle value by 2. And there are other methods of doing this for quadratics, by the way, but on the SAT, this is generally the most common way. So you do 20 divided by 2. This, in this case, is going to give me 10. Quick tip, this here is what is going to appear inside of my root, and you're going to see why, right? This is going to be well, actually, sorry. This here is what is going to be inside of my factor. Okay, this is what's going to appear inside of my factor. Now what I do is I take this value and I'm going to square it. And when I square this value, I will end up getting, let's say 10 squared, which will end up giving me positive 100. This is always going to be a positive, okay, the value here. So if I were to factor this, okay, you're going to see what's going to happen. If I factor this here, it's which two values multiplied together give me 100, but when added together, give me 20x. It's x plus 10 and x plus 10. So you see what we did? So this x plus 10 and x plus 10, well, oh my God, look what we did. Right? So now we have we have something multiplied by itself, which is going to give me that perfect square. All right, so now here I have y squared plus 16y. I'm going to do the same process again. I'm going to do 16 divided by 2. It's always the b value, the middle value divided by 2. Then you take that value, okay, and then you square that value. In this case, it's going to be positive 64, okay? Now, the reason why this helps when you're talking about equation of a circle, and this is probably the tricky part for a lot of students, is that in order to make these equations balanced, because of the fact that I'm technically adding a positive 164 on this side, I also need to add it to the other side. So whatever I add to the left side of the equation, I also need to add to the right side of the equation in order to make this mathematically fair, right? In order to make this mathematically balanced. And I actually kind of like this because what you'll notice here is that positive 164 and negative 20 gives me positive 144. And if you recall, this is an r squared, right? So this r squared equals 144. And hopefully you remember your square roots, right, back in the elementary days. This is going to be r equals 12, right? So I know what my radius is, but do notice that the question is asking you what are the coordinates of the center of the circle? And in one easy kind of change of verbs here, they could have easily just asked you, hey, what's the radius of the circle? So that's the reason why you need to know how to do both of these, right? So if I were to rewrite my expression, here's what I would end up having. I have x plus 10 times x plus 10. And now I'm going to carry my positive sign down. Well, I'm going to factor this, right? This is my second part. And I have y. Now remember, quick tip, the value after you divide by 2, that's what your factor is going to be, right? This is going to be positive 8 in this case, and this is going to be y plus 8, right? So now I have y plus 8, and then this is going to be 144. So my equation of a circle, I'm gonna erase the middle and go up real fast, and I hope that's okay. Remember to take screenshots along the way, and the videos will be sent to you, so you guys have it. And if you're a little confused about why we're doing all this, it's simply because in the very beginning I noticed that I have a standard form here, and I'm attempting to convert to vertex form because I'm familiar that equation of a circle is in vertex form. And if both of those things confuse you, then I definitely encourage you to reach out or simply go kind of sit with your math teacher so that way they can break it down to you in a little bit more detail, okay? My x plus 10 times x plus 10 looks like this. X plus 10 squared plus, now I have y plus 8, y plus 8, y plus 8 squared, right? And then equals, this is 144 and this is 144. Well, look what this looks like, right? I have x minus h squared plus y minus, sorry, k. I'm already like hopping to the answer, right? Y minus k squared equals r squared. So let's break it down. Negative h equals 10. Negative h equals 10, which means h equals negative 10, okay? Negative k equals 8. So negative k equals 8, which means k equals negative 8. So my coordinate should be this. Should be negative 10, negative 8, right? That's what my answer choice is going to be. It's going to be negative 10, negative 8, right? In this order. If they were to ask you, hey, what's your r? Your r is going to be 12 because you would do r squared equals 144, like we've done up here, and that's how you would solve for that. Okay, so to be fair, we did one that was kind of like fairly easy to medium. This one would be considered advanced, right? This would be considered an advanced problem. So I hope in a few minutes, right, you guys feel much better with equation of a circle, right? compared to before. It's definitely manageable, but as I mentioned, a huge tip that I will give you guys is on actual test day, because you're going to be tired towards the end, is that you want to make sure to write this equation down when you first get the test, right? That will benefit you, so that when the time comes and you're in section 4 or somewhere in section 3, you're not exhausted and you don't do a positive sign as opposed to a negative sign, right? Because that could change the, how the equation is going to be used. So I would definitely encourage you to memorize the equation, be able to apply it, understand how it's going to work, and on the actual test day, just write it down. Write it down rather quickly. Not on your bubble sheet of where they're going to collect things, but I would definitely encourage you to write it down somewhere on your test booklet so you have it. Okay, awesome. All right, guys, let's go and let's change up the topics a little bit. Some of you had asked for an advanced triangle problem, and I'm going to slide down here. I think the advanced triangle problem was this one. Now, I don't think you guys have done this with Mr. Brett yet, if I recall, and I think that might have been also one of the reasons why you guys reached out, was saying, hey, I'd really like to do this problem. So I wanted to explore this problem again in terms of geometric shapes, because it's also, this is probably, I would say it's fairly advanced, because there's a lot of different steps that you kind of have to consider, okay? And as always, we are identifying what the concept is, and we are trying to figure out, okay, what is given inside of the problem, and how we kind of interpret this. So it says, in the figure above, AB is equal to AD. BC is equal to CD, and it says BC equals 4, and AC equals 10, and then it says, what is the area of ABD? Well, the first thing I'm going to label is what they're looking for. So here I have A, B, D, okay? And they want to know what the area is. So I should immediately register area of a triangle, right? So area in this case of A, B, D, right, of this triangle is going to be 1/2 base times height. My height is going to technically be, if I had to break this down, just so I know what I need to look for, my height is going to be this. My height is going to be AE. So height is AE. And my base in this instance is going to be BD. Okay. I think that's kind of what I need thus far. Now, the question is, right, why are they giving you all this other stuff, right? Like, how does this impact? So let me start labeling first. BC equals 2. BE equals 2. BC equals 4. And then it says AC equals 10. So I do notice that they give me the entire line. This entire section here is 10. They do not give me the AE. So what I do know is that AE plus AC will give me my AC. Sorry. So AE plus EC. Okay, AE plus EC will give me my AC, which should be 10. So this is probably going to be subtracting of these, right? Which is probably where that minus sign is coming from. If I'm plugging things in, I hope this helps so far and as I'm interpreting. Now the question is, why are they giving you AB equals AD and BC equals CD? Like, what is the purpose of these things? Most of the time in triangles, whenever I have a triangles problem, there's usually three core things that I want to think about. All right, the first is by far the most popular is right triangles. They love right triangles so much so that they even give you special right triangles found inside of your reference section, right? So that you want to pay attention to that, because if you see like a square root somewhere, like for instance, radical 2 or radical 3, 9 to 10 times is a special right triangle. If it is a right triangle in general, then you immediately move to what you refer to as your Pythagorean theorem. This should kind of be crossing your mind. Also, you want to pay attention to SOHCAHTOA, if they throw the word sine or cosine or tan. In this problem, it seems as though, because I don't see a sine, I don't see a cosine or a tan or anything, and there's no angles within, I'm probably not going to be using SOHCAHTOA, okay? However, I do think I'm probably going to be using this because I do notice they give me two sides, right? In terms of one could technically be the hypotenuse, and then I could use my special right triangles as a reference if necessary. So I think the idea is this: if AB equals AD, right, meaning that these two sides are going to be equivalent, and it tells me that BC here is going to be equivalent to CD. I think what that is telling me is that because of the position of the triangle, let me erase these things. Okay, because of the position of how things are being held up, and maybe if you think about this just in terms of like a miniature TP, if you will, right? If I have something like if I have like a pole, or if I'm trying to hold something up, if I take one stick that's exactly two sticks that are exactly equal length, then this thing here, this stick that I'm attempting to hold up, is going to be exactly standing up straight. And if it stands up straight, we refer to that as perpendicular, right? So this is a 90-degree angle, this is a 90-degree angle. Providing that these two things, or these two holsters, if you will, right, are kind of positioning it, it will stand up exactly straight and it won't tilt at all, because this is an isosceles triangle, right? This is an isosceles triangle and this is an isosceles triangle. The intention of them telling you that, though, and to be fair, so you're not overthinking this, is to tell you that here I have perpendicular angles, and these perpendicular angles are all forming 90 degrees. Well, why does that help me, right? That's what you want to evaluate. And the reason why this matters is because let's pretend I take my B, C, here's my B, here's my C, and then here's my E, right? That tells me that now I'm working with, I can use special right triangles, or I can just use Pythagorean theorem, right? This is the side that's across from my 90 degrees. So this is referred to as my hypotenuse. So if I do Pythagorean theorem, I have, and let's just label this. I'm going to say that this is a squared plus, and I'm just going to even say EC, right? This is EC squared, right, here. I just label that side. And then this is therefore going to be 4 squared, which is my DC, okay? And let me just simplify this here to save a little bit of time. This becomes 2 squared, okay? So 2 squared plus EC squared equals 4 squared for my Pythagorean theorem. This becomes 4 plus EC squared equals 16. And then as I subtract, I get EC squared equals 16. I want to figure out what it is. I get a radical. Let's pretend you get confused and you're like, oh, I don't know where to start. Once again, using answer choices as a guide, ta-da, right? to make it easier for you. You almost know you have to have a radical 3. So you're thinking to yourself, okay, what is perfect that goes into, sorry, it's not 16 either. Just realized that. It's not 16, it's 12, right? And if this is radical 12, right? So this should have been 16, apologies. So I have 16 minus 4, right? 16 minus 4 is 12. So EC squared, take the radical of both sides. So now I want to figure out, okay, what's radical 12? And I want to break this down to what is a perfect square within, and it's going to be 4, and then it's going to be times radical 3 here. So this 4 is going to break down to 2 radical 3. And that seems like that is what my, which section? AE here. So here's 2 radical 3. Good. I could have technically, I believe, used special right triangles, but either way, it's totally fine because like 30, 60, 90, etc. There's no it's generally better to be able to do the Pythagorean theorem because there are instances where right it might take you more time. So here's the 2 radical 3, and I noticed that the entire thing here is 10, right? And then this EC here is my 2 radical 3, and I'm trying to solve for AE, right? Back to the whole. So in order for me to solve for AE, let's erase this, right? We're done with the Pythagorean theorem now, or at least we think we are, right? And then now I'm going to do AE equals 10 minus 2 radical 3. Here's the thing though, I'm not quite done because of the fact that I just, out of all of this, right, I just solved for my height. I still need to solve for my base. Now, because of the fact that this is a 4 on the side and this is 90 degrees, and these are equivalent, and this is a 4 on the side, and these are also 90 degrees, that tells me that ED here is also going to be 2, right? So this side here is going to be 2. So what I end up getting when I do my entire area of a triangle is area equals half of base times height. My area is going to be half of, and this is going to be 4, because it's going to be both of these together, right? It's BD altogether. It's 4, 2 plus 2. And then my height, which was the hard part to figure out, is 10 minus 2 radical 3, okay? I can almost tell you that D will not be my answer because of the fact that I have to multiply these out, and they just anticipating, hey, you just solved for the first step and you didn't actually continue solving for what you need. So quick tip, that's always why I circle the thing that I'm looking for, so I don't make that common mistake, because they will anticipate for you to essentially stop early. Then what I do is I want to multiply these. So let's make a little bit of room. And as I do this, I get 1/2 times 4, so I get A equals 2, and then times 10 minus 2 radical 3. I want to distribute my 2, so I get A equals 20 minus 4 radical 3, and C is my answer. Okay, so there's this was definitely, I would say, a fairly advanced. There were a lot of different things to consider, but most of the time on the SAT, whenever you see triangles in this sense and there's no angles, you kind of want to almost immediately lean towards special right triangles and Pythagorean theorem. That's 9 out of 10 times what they're going to be evaluating. There might be instances where they will do similar triangles, but I noticed that they never actually gave me the other sections to the other sides, like A, B, or D. They never gave me any of the other kind of sections, right, for that. Okay, let's move on. I hope this is helping, guys. I hope you guys are getting a lot out of it. Let me check the chat real fast. Okay, my laptop, I don't have my charger. Oh, not a problem, guys. Remember, if for whatever reason, if your laptop dies or whatever, remember, we always take the liberty of kind of posting the videos for you guys, so it makes it easier. Okay, so I know that a lot of the questions that we're doing today, also, to be fair, are fairly complex, and they take a little bit longer to do than some of the others. So we'll make sure to definitely have the videos out to you, so you can kind of use them as your reference. I'm going to do a volume, area, and perimeter problem that is going to be on 160 here of your book. And the reason I'm going to do this problem is because I don't think technically you guys have done volume, area, and perimeter just yet. So I'm gonna show you. The first thing is, whenever they mention here, and then you see a symbol and it's like volume or it's like a cylinder or pyramid, something, immediately your mind should jump to the reference section. You immediately want to be aware that something is most likely going to be in your reference section for you. And if I quickly go back, right, here's your reference section, right, inside in the beginning of each section. Then here we are. This is most likely the equation that I'm going to need to utilize in order to do this type of problem. Okay, so be mindful of that fact that whenever you have volume or area and they give you a specific type of shape, you 9 out of 10 times will be utilizing something from the reference section. Right. Second key point is that be mindful that if you were in open-ended, okay, if you're in open-ended problems, then you also want to pay attention to, obviously your answer needs to be positive, but, and this is what you want to pay attention to whenever we're talking about volume such problems, if there's no pi in your answer choice, then you need to be prepared to plug in 3.14. Okay, plug in 3.14 if you don't see that. Okay, depending on what they're giving you and depending on how you work it out. Just be mindful of the fact, because in this equation, right, let's go back very quickly. It is volume equals pi r squared h. Okay, that's my equation. So volume equals pi r squared h. That's what I'm kind of encouraging you to understand, right? How we set this up. A dairy farmer uses a storage silo that is the shape of the right circular cylinder. Boom. Mentally, volume, reference, these are things I want to pay attention to, right? That's how I want to be able to interpret the problem. If the volume of the silo is 72 pi cubic yards, what is the diameter of the base of the cylinder in yards? So the diameter of the base, well, the diameter of the base is really going to be the diameter of the top as well. What you do want to notice is that r is, well, 2r is actually the diameter, right? Because the diameter is all the way across. Also notice that, to not overthink this, okay, pi r squared is the area of a circle like this. If I take that area of a circle and if I just basically like extrapolate that, right, all the way down, that this being my height, that's where I now have a cylinder. Okay, so here I have my pi r squared, that's the area of a circle. The moment that I add an h, pi r squared h, now I'm doing this times every little section, right, of the, so that's why it becomes the volume of a cylinder now. So you just want to kind of notice how the certain equations kind of connect to each other. So 2r equals d, and I have 72 pi equals pi r squared h. The first thing I can do is I can probably plug in my 8 for h. From what I can tell is 72 pi equals pi, and then r squared times 8. I can divide both sides by 8 pi, because this will cancel, pi's will cancel. And if I divide this side by 8 pi, then notice what I'll get. I'll get it in r, essentially. So here's pi's cancel. 72 divided by 8 is going to be 9. And here I have 9 equals r squared. I then want to, and for all intents and purposes, the SAT tends to focus on the positive value for square roots, right? They call that like the principal square rule. And so if I do the square root like this, then I get 3 equals r. But remember, I'm not done, because I didn't make the lazy mistake of not circling, right? What is that they're looking for? It says, what is the diameter of the base and cylinder, right? The diameter equals 2r, right? So I'm going to do 2 times 3 equals 6. So 6 should be my answer. That's what I essentially would kind of plug in, right, for my answer choices. 6 should be my answer. And I also want to notice that it's positive. There's no pi, right, which works for open-ended questions, and that I don't have the radical inside of my answer choices. So 6 will be the answer to this question. Okay, all right. Let's move on. Let's do this one here, where you kind of another volume, another cylinder. They love cylinders, by the way, right? It says a glass pictured above can hold a maximum volume of 473 cubic centimeters, which is approximately 16 fluid ounces. One thing I noticed is they're giving me 2 units here, so I kind of want to skim up. It says, I see, because this question was originally for multiple questions. So that's the reason why they're giving you more than what is needed. Most of the time in the SAT, per question, they do not give you excessive information, right? So the reason why it seems like you have more than what is needed is because the information here is relevant to multiple questions. It says, what is the value of k in centimeters? Well, I want to find one. I want to find where k is. K is here, and here, and here. But most importantly, k is here. And the reason I like this the most, because it says volume, and it says 7 pi k to the 3rd power over 48. is because it tells me what these are going to be. Now, if you're guessing, hey, which of these do I use? Do I use the 473 for my volume, or do I use my 16 for my volume? What you want to pay attention to is your unit, right? Because it says in centimeters. So I'm intentionally going to use 473 because it's in cubic centimeters, right? And then this equals 7 pi, and this is k to the third over 48. Now don't worry about the units anymore. Essentially, since we've like labeled these, they're totally fine because this is in centimeters, this is in centimeters. I don't have to do any more unit conversion, so I'm really not going to pay attention too much more to the centimeters cubed. What I do notice though, and this is fair to you, notice there's no pi. Because of the fact that there's no pi inside of my answer choices means I will have to take this, and I should expect to do 3.14 equals pi. So I basically want to be able to be prepared to plug that in as I solve for this. Now, my goal in this instance is to isolate and is to solve for k. So if I'm going to isolate and if I'm going to solve for k, then I want to first cross multiply. And I'm going to use a calculator to save some time because I believe this is the calculator section. So 48 times 473 is going to give me 22,704. A big suggestion I will give you is do not round until you are finished with the problem. I'm purposely going to leave this blank at first. And the reason is because you notice that these are already in decimal. So at the end is when you want to round to try to get something as close to the approximation for what you see. All right, hope that helps. Now, here I have 22,704 equals 7 times something k to the third. You notice I left the pi out on purpose. So I'm going to quickly recap. The reason why I did this is because I know that I'm going to have to do 3.14. Well, how do I know this? Because there's no pi inside of my answer choices. So I need to be prepared to simplify pi by doing 7 times 3.14. This will give me 21.98 k to the third power equals my 22,704. I now want to divide both sides by 21.98. This simplifies, right? This becomes 21.98. You can kind of almost tell that this is going to be like around 1,000, right? This is around 22. This is around 22,000. And 1,000, right? The cube root of 1,000 is going to be like 10. So I'm probably going to be leaning towards looking at my answer choices, probably closer to D, but we're still going to do the math to prove it. So you have 22,704, and then divide it by 21.98, and I end up getting 1,032.94. And notice I purposely took it to the second decimal, right? I'm not rounding all the way until the very end, and this becomes k to the third. I'm going to do the cube root, right? Cube root of this, and I get, let's see here, cube root on the calculator. I'm going to do this into the, say, and yes, I end up getting 10.11. Now I round equals k, and my answer is yes, it's D, very clearly, okay? You'll notice a few quick tips, right? So you don't get stuck, like as you're working through, is that I am constantly using the answer choices as a guide. I'm constantly saying to myself, okay, mathematically, which step do I take, right, as I go through, based upon what it is that they're asking me to find, and based upon what is given, and based upon what the answer choices have. Otherwise, I would have just sort of stood there like, well, what do I do with 3.14? Granted, hopefully at the very end, you would realize, oh, well, I have to take, I basically have to now figure out a way to remove pi from my equation. Hopefully that doesn't kind of intimidate you too much, but I'm constantly using the answer choices as a guide to evaluate what is going to be the best course of action, okay? Let's go to, see here, I believe there's one, yes, okay. So many of you asked for this problem here, and this was on various channels that we have, so I wanted to kind of quickly do it. But before I do, and before I hop into this, I'm gonna check the chat real fast. Let me know if you guys have any questions as always. Okay, all right, seems like we're good. All right, so I'm gonna move into this one now. It says, A square is inscribed in a circle with a radius of 6 radical 2 inches. So that means, okay, so what it means that something is inscribed in something else, it means the something else is kind of the larger of the two figures. Not the best circle, but you guys get the point. The square inside means that I will have kind of 4 equal sides because it is a square after all. Okay, so the square means that the square is inside, right, inside the circle. It does say a radius of 6 radical 2 inches. So my radius for my circle, now remember, radius always comes from the center of the circle to the furthest endpoint. So the radius would go like here, or sorry, it would go, let's say, to here. But what I notice is, and this is probably the more important thing, is that I want to go from the center to an endpoint that also somehow relates to the square. That's what I'm attempting to do, relate to the square. Otherwise, there's no, right, there's no significance to having the square inside of the circle, because the square here has 4 equal sides, and I kind of want to pay attention to that. And by the way, overall, it says, what is the perimeter of the square in inches? So what is the perimeter of the square in inches? This is in inches, this is in inches. Don't have to worry about the unit anymore because it's set. I want to quickly identify that most likely the way that these relate is based upon the diagonal. Because you know what I did here? Here I have a radius, right? This is a radius from a center to the endpoint, but that is kind of tangent, right, to my circle. So here I have another radius, right? By the way, these are equal, right, as we should recall. So this here and this here, this is an isosceles triangle. Whenever I have a triangle, essentially with my 2 equal sides, okay? Whenever I have a triangle with my 2 equal sides. And if I theoretically keep going, right, if I draw this, because this is 2 equal sides, and if I kept going, okay, here, technically this is 180 degrees. So that means that this section here and this section here, these are actually perpendicular, right? If I kept going to the outside point, I do a full line, because the diameter cuts the circle exactly in half, which means I would form a perfect line or a perfect 180 degrees. So this is going to be 90 degrees. This is going to be 90 degrees. Well, now I'm in special right triangle mode, right? In special right triangle mode, let's go back to this one more time. Right, whenever you have special right triangles, feel free to use your special right triangle references. So here's 45, 45, 90, right? And here I have S root 2. So, well, how does this relate? Well, if I do here, right, this side and this side are going to be equivalent. So here's S. This side is not equivalent, right? I was just drawing that in proportion to the sides. Then I can figure out, okay, well, this is SS, then this is S root 2. Well, technically, right, technically, this S here is the 6 radical 2, and this over here is the 6 radical 2. So what I could do, right, I can do this 2 different ways, and I'll show you both so it makes sense. And most of the time, if you remember special right triangles, then this will help you. So if this section here is S, and if this section here is S, both being the radii here of my circle, which are going to be acting as kind of the partial diagonals of the square, then this becomes my 6 radical 2, but then times my other radical 2, right? This would be like S and then S radical 2, right? And that's according to this condition here, right? What's across from the hypotenuse is S radical 2. So, but going back, making this easier, if I multiply this, then I end up getting 6 times radical 4, which just becomes, basically this simplifies, this becomes 6 times 2, which equals 12, okay? Let's pretend you didn't see that like so clearly, but you do understand that you have a right triangle, okay? So, because now we know that this is gonna be 12. We know probably this side is gonna be 12, this side is gonna be 12, and this side is gonna be 12. Therefore, the parameter is most likely gonna be 48. But if you don't notice this step here, then it's tough for you to solve the problem. So here's what you always do if you get stuck. And knowing that you have a special right triangle with 90 degrees, you're going to do Pythagorean theorem. Remember, the side across here is what we're trying to find. So we're trying to find c squared, right? And a squared in this case is going to be 6 radical 2, okay, squared plus, and then this is another 6 radical 2 like this squared. And whenever I do the exponents here, 6 radical 2 squared, this is going to be 6 times 6, right? And then radical 2 times radical 2, if I set them up this way, right? Just as you might recall, right? Like this. So this becomes 6 times 6, which is 36. Radical 2 times radical 2 becomes radical 4. As we already know, radical 4 breaks down to become 2. So then this is really 72 plus, and like doing this all over again, this becomes 72 equals c squared. Well, 72 plus 72 is 144. Check that out. 144, right, equals c squared. That means that if I were to simplify just for this side here, right, just this side, then I end up getting, right, if I take the radical like this on both sides, I get 12 equals c. So both ways I end up getting the same answer. That's what I'm trying to tell you in terms of the relationship. If you don't immediately see that this is special right triangles and don't necessarily, and you perhaps get confused of how to set it up, or perhaps you forget where it is in the reference section, that's totally fine. But there are other ways of solving the problems is basically what I'm trying to articulate. Now, am I done the problem? No, right? Here's the reason why I'm not done either way is because I noticed that I have 12, 12, 12, and 12 because it's asking for what is the perimeter of the square. So I basically have to do 12 times 4 because I have 4 different sides, and 48 is my answer. So 48 will be my answer for this problem here, and I did my best to kind of show you 2 different ways to do it, whether it's special right triangles or indeed Pythagorean theorem, okay? All right, guys. Because I want to give you guys a little bit of time to ask, and many of you had various questions regarding college admissions, do me a favor now, start putting some of those questions in the college admissions, or start putting those questions in the chat, and then I'll do my best to answer them. I'm going to grab 1 or 2 other types of questions to kind of show you how to approach these and make it a little bit easier for you. But to save some time, feel free to drop any questions you might have. Certainly regarding anything in general you want to know about college admissions, right? if it makes it easier, okay? Feel free to put them in the chat feature, and I'll happily answer them. All right, so here, let's back up real fast. Okay, on the SAT, you will have various questions regarding data analysis and statistics. Now, for statistics, and to simplify this, a lot of times this is your mean, this is your median, this is your mode, range is often asked. You will often get, I would say, survey or study questions, which is what we're about to walk into, right? To survey or study how best to conduct like experimental design, essentially. And then you might even have questions every once in a while regarding, I would say, like standard deviation, scatter plots, things of that nature, okay? So what we're about to do now is we're about to do a survey and study question. And whenever you do surveys and studies, there's essentially kind of 3 key components. It says to determine the mean number of children per household in a community, Tabitha surveyed, this is my huge hint, 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following statements must be true? Whenever you have a must, you're looking for the most reliable answer. And also, because, let me rewrite this, most reliable answer. Like the answer that definitely can't be crossed off. That's what you're looking for, okay? When referring to surveys and studies, there's 3 conditions that you kind of want to pay attention to. The first is that it is random, okay? The second, that it is a large sample size. The SAT generally prefers for it to be, I would say, usually like 100 participants and more. Although here it says 20 families, so you technically don't know. I mean, technically, I guess it's 20, which isn't great, but at the same time, there is kind of the trump card, which is that if they have bias, right? So they want to remove bias from the questions. The most popular forms of bias are the question types, the location, which they try to kind of sneak in there, right? And the group that is being asked. And I'll give you a perfect example. Obviously, you can see that I'm wearing a Sixers hat. Yay, go Sixers, right? So if I wanted to conduct a fair, right, you want it to be fair, a fair survey of how many people love the Philadelphia 76ers, the place I would not go is to a Sixers home game, right? Like, because I am immediately eliciting bias in terms of the type of people that I'm asking and the location of where I'm going, okay? That's what I mean by eliciting bias, of like putting bias into the sample. Even if I ask all different sorts of people that are there at that location, it is assumed that the reason why they're there at that location is because of the fact that they do enjoy or they do want to like watch the Philadelphia 76ers. So there's a quick kind of tangent for you guys, right? So when you're doing these problems, the thing you want to pay attention to most, more than anything else, is the bias, because that is where they'll be sneaky about it. And sneaky because they will use words like the location and the types of people they're asking, like their group, right, as they do this. I've seen them do this with probably, I would say like 4 or 5 different various questions on the SAT. It's usually probably 1 to 2 questions per test. All right, so here we go. Let's interpret this. We have to determine the mean number of children per household in a community. Tabitha surveyed 20 families at a playground. Okay, so first of all, 20 families is not enough. Like realistically, she should have asked for more. However, trump card, she asked for how many people have children, right? This is the purpose of the study. How many people have children? And notice where she went. She went to a playground. It's assumed in this case that if they're at a playground, they probably have kids. That's the assumption, right? If they're at a playground, they most likely will have children in order to enjoy the playground. So for 20 families surveyed, the mean number of children per household was 2.4. Well, this number is probably true, but the fact of the matter is her collection, her data collection makes the study invalid simply because of the fact of who she asked and where she asked it. Right, so let's go down and look at our answer choices. The mean number of children per household in the community is 2.4. It may very well be, but I highly doubt it because she only asked people to playground. A determination about the mean number of children per household in the community should not be made because the sample size is too small. I would have to say this is probably the answer that most students would select because of the fact that 20 families isn't a lot. However, the sampling method is flawed and may produce a bias estimate of the mean number of children per household in the community. Well, yes, it's flawed. How is it flawed? She went and she conducted the research at a location that elicits bias into the sampling of the collection. So even if A is true, and even if B is somewhat true because she could have asked more people, right? C is definitely true because of the fact that the only people that she asked were individuals at a playground with most likely with children, right? And that's the assumption that you kind of have to make. So C is going to be our answer to question number 26 in this sense. But always, whenever you're doing any sort of study survey question, the moment that you see the word survey is kind of the red flag that this is where your mind goes. You want it to be random, asking a number of different people from some various places, large sample size as much as possible. Do your best to remove the bias, and the bias is generally in the types of questions they ask, the location where they're conducting it, and the group or the individuals that they're asking. Okay? Most of the time, this is the most, I would say, important thing that the SAT is referring to. So you want to do your best to kind of remove bias. All right, guys, so we had a chance to cover some dividing polynomials, right? Synthetic division, factoring, equation of a circle, a few coordinates and graphing problems, which we'll definitely touch on more next week, advanced triangles, volume, perimeter, a lot of equation of a circle too. So I hope you guys got a lot out of that. What I'm going to do now is I'm just going to open it up for general questions in the last. Have a great weekend. Enjoy your week. Take care. Let me know if you need anything. All right. Bye, guys. Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.